Now, question 9 is another question that uses a graph. And so I included two graphs at the end of the practice, and you're supposed to decide which one is the correct graph to use, and then find when does the function reach the value in question. Well, this is, if you recall, this is the one we used for, I believe it was question 6, and the value we were attaining was $12,000. Y is in thousands. For this question, though, we are, we're also, really, are we going, are we trying to find, yes, 12,000, interesting. I don't know if that's a coincidence or not. I wrote this so long ago, I can't remember. But if you skipped question 6, you know, and you are looking at question 9, is this a increasing or decreasing function? Well, it says the denominator increases faster than the expression in the numerator, and the expression in the numerator is 1 minus a decreasing exponential function. And so since this is decreasing and this is a linear function here, we know that it doesn't decrease very fast, but this does decrease rather quickly. In any case, another clue that this is a decreasing function is that this is present value, and each compounding period reduces the present value. We want to find out the interest rate that exhausts the present value. So present value decreases. So that's a very awkward explanation, but bottom line is present value is a decreasing function and future value is an increasing function. Okay, so this is the graph we're going to use, and we want to find out when this function value here, when does it hit 12,000? What rate, what interest rate makes this function hit 12,000? Well, we can see that it's very close to 1.5. It might not be, but 1.45 or 1.4. Actually, it's not 1.4. But anyway, it's very close to 1.5, so an estimate of 1.5 is good enough. So that is the interest rate per compounding period. It's not the interest rate, it's the interest rate per compounding period. Sorry, it took a lot longer than it should have. Okay, and now finally, in question 10, we're buying a house. You're buying your first house. It's only $96,000. Good luck finding a house for $96,000. You can find maybe a little garden home in a nice subdivision, or a starter, a fixer-upper, or something like that. But anyway, you're buying your first, and the book is several years old, okay? So that's my caveat to this value. So you're buying your first house for $96,000. The mortgage company is going to require a down payment of 15%. But if you pay 20%, you avoid paying mortgage insurance. And so that's what you are going to pay. Now they are offering a 30-year loan at 4.5% compounded monthly, and we want to know how much, you would like to know how much your monthly payments are going to be if you put down 20%. We're also asked how much they will be if you put down 25%. So, since our present value is equal to the price minus the down payment, then we find the amount of the down payment, 20% or 0.2 times 96,000, and that's going to be 19,200. I hope you've got that much scraped up before you go buying your house. And you subtract that from 96,000, and so our present value is 76,800. For 25%, we multiply 0.25, and that changes the present value to 72,000. And the calculations are both shown here. Now the keystrokes are kind of long and complicated, and again, this formula has two. It's shown two different ways in that section in the text, and for whatever reason I've chosen to use this one. I don't know, it just looked like it was the one that would be the easiest to enter in. Now I didn't calculate, I didn't find out what the I was first, although that would simplify our calculations. The question that I am asking on the test will allow you to do that, and you'll get a decimal that terminates after only a few digits. This one, if you divide 0.045 by 12, you'll get 0.00375. So it's 5 digits long, but it doesn't go out, for very far. 5 digits is not far. Anyway, here are the keystrokes, and I'm making these calculations for 72,000. The only difference between these calculations and these is that this first figure would be 76,800 instead of 72,000. But I type in 72,000 times and left parenthesis for my numerator, and it's 0.045 divided by 12, and you close your parentheses, so there's divided 0.045 divided by 12, close your parentheses, and then enter divide. If you already calculated this out ahead of time, you wouldn't need these parentheses, but you would need these. You would need parentheses for your denominator. And so here's the parenthesis that starts your denominator, and so we need a 1 minus, so that's here, 1 minus, and then we need a set of parentheses again for this exponential expression, 1 plus 0.045 divided by 12, or the value that I gave you earlier. And then you close those parentheses and you press the caret exponentiation key, and then for the graphing you need parentheses before you enter in the negative button. So there's a left parenthesis before entering in the negative button, and then you multiply 12 times 30, and again you would think that we would need a parenthesis here at the end, but for some reason, no, you don't. You can just hit enter, and you will get, since this is 72,000, you will get $364.81. For the scientific, everything is the same, except again, when you press this exponentiation key, this little caret symbol, that puts you up in the exponent, that data entry line, and so then you can type in the minus, the negative sign, and 12 times 30, and you hit enter, and the calculator knows when you hit enter that you're getting out of the exponent, you're getting out of all the entry, and it does your calculations for you, and you have this payment. And I don't know how long I've prattled on here. It seems like this was a long video, but I hope that it's been informative.